Good afternoon to everyone. I'm pleased to be here with Engineer Tania. Thanks to CUMIPAZ 2018. I'm going to expose a topic that you might have heard in action movies as a very fashionable or superheroes topic. Generally, this technology is understood as something futurist, as science fiction that is being applied. So, next, I'm going to be speaking about nanotechnology and its applications in renewable energies. In the next slide, we can observe some basis for nanotechnology. First of all, to tell you that is the study, design, and synthesis and the manipulation to a nanometric size or a nano scale. We speak about that size. Nano means 1 times 10 nanotechnology between zero point 0.n and 100 nanometers. What happens with this technology is that we have two phenomena, very important ones. We don't have the classical mechanics to that, like gravity or the action and reaction law, but mechanics. But quantum mechanics, which is based on probabilities, allows the materials to act differently. Other of the opportunities with nanotechnology is that the materials also have more surface, which means that they can be more reactivity and more storage in a smaller space. In the next slide, we see that nanotechnology, as I mentioned, is not something from science fiction, but it's something that applies to our daily life. Products have been developed and services, innovative services and products in nanotechnology. We know that investing in this technology means generating new products that can also support sustainable development. Currently in the market, as of yesterday, there are 8,412 products of nanotechnology developed by over 2,000 companies in 56 countries. As we can see in the slide, it applies to agriculture. We can have fertilizers using biopolymers, as it is the work as developed by Daniela Cuadras. Maybe she can stand up in Valle University. We're working together with the subject of biopolymers. I'm going to be pointing at some students from chemistry subjects. Also the environmental subject, we can see the development in materials for photovoltaic energy, also renewable energy, water treatment, and food. We can also see new packages developed with this technology. In medicine, we can also see the treatment for medicine and medical devices, which allows a better action in a smaller volume, which allows them to be more flexible and to be taken to rural communities. Also in electronics, we can observe in our cell phones. I think we all have a modern phone that uses nanotechnology. We have seen the evolution of computers, how we have passed from having a computer, very big computers with little capacity, to having very small computers with very big capacity of storage. So all these advances, we take them to nanotechnology. And there's also another example of construction. New materials are being developed for this area. As you can see, these figures of 7 applications that are many more applications, because nanotechnology is very versatile and that allows it to be applied to many different fields. In the next slide, we'll see nanotechnology and the sustainable development. It's important to mention that with nanotechnology, new discoveries have happened for treatment of water, for clean energy, for medical devices, for green chemical, for manufacture, for sustainable materials and technology that allows to have a better education. Next, please.
Algunas de las
Some of the applications of nanotechnology and renewable energies is based on improving the photovoltaic devices, solar devices, making devices at a low cost. This I developed during my doctor's degree in the University of La Mancha. We used to do solar panels with 2 different types of molecules so that they could work in a better way. There are also researchers that are developing batteries more efficient and also of a long duration and not with such a short life as we have it right now. Materials more resistant are also being developed. It is important to know that nanotechnology is being applied to this revolution of renewable energies and accessible energies as approached for the seventh ODS, which is accessible energies and non contaminant energies. We're also applying in Guatemala some topics of nanotechnology for the construction. I'd like to ask Jennifer Bynes to stand up. Engineer Jennifer Bynes, she was working her thesis in photocatalytic structures. She was working her thesis with Cementos Progreso, University Progreso from Guatemala, with the support of the National Secretariat of Science and Technology through a multi-seat in which we developed a product that has the potential to be applied in schools and in hospitals. It's a structure with nanotechnology that allows to have some properties of self-cleaning, antibacterial, and has big potential. Likewise, we're working with cements more resistant using nanotubes, thanks to the financing of Towards Research Grant, which is a financing agency in Italy for countries in development. Catherine Callejas is working in this project. Is she here? So as you see, we have many people from Guatemala with potential in the area of science, which are developing products that seem to be from science fiction, but they are real. We're also working in a project of nanomaterial for the sustainability of communities in Guatemala with an emphasis in stoves that save wood with the support of the universities from Spain. We're also working in the University of San Carlos from Guatemala, other projects of research developed with an orientation towards the sustainable development. This is one of my favorite projects because we see how renewable energies and connectivity can reach rural communities, and we start to see some indicators of sustainability for communities that were isolated, which means that these communities being far from the normal network of electricity can, by renewable energies, have access. We started with communicators thanks to the support of Fulbright Nexus with a case study from Nataculba, Chile, and then we started working with a startup from the University of California, which is New Sunroof. Thanks to the support of Microsoft, we generated this first pilot project, with renewable energy through solar panels and connectivity for a rural school. In Guatemala, we have over 1,000 schools that do not count with electrical energy, and we have a big amount of schools without internet. This is our first pilot project in which we're benefiting over 85 children. In the mornings, this is being used for children at school, and in the afternoons for the community usage, so that this interchange of knowledges can be given so that people can learn how to use computers and how to use the internet, and to know how to improve their crops, how to improve the productivity that they are generating. This first pilot also, we have something very interesting here, which is the usage of a hardware and a software that handles the energy and that allows us to control. And when the community needs more energy for the usage of a drill or any other kind of equipment, the energy can be focused for the things that need more energy, so the energy is used in an efficient way. In the next slide, we have also projects, the integral management of waste. This thanks to the international consortia, as well as the financing of the National School of Science and Technology, which we have been identifying some obstacles for the management of waste, making a transference from the University of Fraunhofer in Germany, as well as the Yeto in Polony, who are making a transference of knowledge towards Guatemala, and we're also generating a motivation for the new entrepreneurs so that they can focus on the projects of new companies for the management of waste. And we're finding new business opportunities with the management of waste. Last week, we had last event for the selection of the winners of the contest, and there were wonderful ideas. So we live that here in Latin America, we have the potential, and we leave it with over 100 proposals for the management of residues or waste and how to better the future of new generations. We're also working on opportunities for new entrepreneurs as a result of the research with a project from the European Union, the Erasmus Plus, in which two universities participate from each country of Central America, a public university and a private university. We are developing actions to foster the systems for the new generations. Next, please. Last, I'd like to finish saying that we need to have the technology as a tool for sustainable development and for the integration for peace. In the next slide, I'd like to share an event in which I was with Senacid and also with the Ministry of Education, a fair of the youth, to tell you that we should not forget that the girls can. Girls can do things. This is a photo for women. You can see an image when I was very little. This is typical fabric. I'd like to tell you that if it wasn't for the support of my parents and the support of my people around me, I wouldn't have been able to become a scientist. And I'd like to tell you that girls can. Girls can do things. Thank you very much. Many times we limit the girls by telling that they can only play with balls or with dolls. And the boys, they receive spacecrafts, Legos. It is important to create that foster for science in girls too, and tell them you can too. In these activities that we have developed in information, I have found in groups of 25, at least 5 girls, that they haven't been able to study. They told me that they have been able to study the careers that they wanted because their parents told them that those careers were for men. Mechanical engineering or any other career that is understood to be only for men. That still continues to happen here in the city, in rural areas, and I tell you, please, let us change that mentality. Thank you very much.